Assalamu alaikum. I am Muhammad Ali Hassan, Senior Lecturer, Department of Mathematics, Milestone College. I hope that student you are well. I am also well. Today I will discuss about differentiation exercise 19. So let's go student, look at the board. Question number 47. ddx of tan sine inverse x. Now ddx of tan sine inverse x. So let sine inverse x equals to x. We know that tan x. Student, you have learned ddx of tan x equals to sec square x. So using formula, tan x means sec square x. Again, differentiating with respect to x, sine inverse x. So student, using formula ddx of tan x means sec square x. Again, differentiating with respect to x means ddx of sine inverse x. Now using formula, we know that sec square theta equals to 1 by cos square theta. Theta means sine inverse x. And again using formula, ddx of sine inverse x equals to 1 by root over 1 minus x square. You have learned, student, ddx of sine inverse x equals to 1 by root over 1 minus x square. So next line we have, again using formula cos square theta. Cos square theta means 1 minus sine square theta. Here theta is sine inverse x. Then we can write 1 minus x square whole to the power half. Root over means whole to the power half. Then 1 by root over 1 by 1 minus sine square theta means sine theta whole square. Then we get 1 minus x square whole to the power half. I say again, student, here 1 minus sine square theta. Sine square theta means sine theta whole square. We know that sine inverse x equals to x. Sine inverse x equals to x. Then we have 1 minus x square, and here power is 1, and 1 minus x square whole to the power half. So we get 1 by, here 1 minus x square whole to the power 1 minus x square whole to the power 1. So we can write 1 minus x square equals to 1 minus x square whole to the power 1 plus 1 by 2. So we have 1 by 1 minus x square whole to the power 3 by 2. So student, I say again, here sine inverse x equals to x. So 1 minus x square into 1 minus x square whole to the power half. So we have 1 minus x square whole to the power 3 by 2. So result will be 1 by 1 minus x square whole to the power 3 by 2. I hope that, student, you are clear. Question number 52. ddx of root over sine inverse x to the power 5. So let sine root over x, here x means sine inverse x to the power 5. We know that, student, ddx of root x equals to 1 by 2 root over x. We know that ddx of root x equals to 1 by 2 root over x. So here sine inverse x to the power 5 is x. Now using formula root over x means 1 by 2 root over x. X means sine inverse x to the power 5. Again, differentiating with respect to x means d dx of sine inverse x to the power 5. Again, here using formula d dx of sine inverse x. Here x is x to the power 5. Now, here next line 2 root over sine inverse x to the power 5, and again using formula sine inverse x. So sine inverse x means 1 by root over 1 minus x square. Here x is x to the power 5, then whole square. 1 by root over 1 minus x square. Again differentiating with respect to x of x to the power 5. Now we can write 2 root over sine inverse x to the power 5 and 1 by root over 1 minus x to the power 10. 1 by root over 1 minus x to the power 10, and using formula x to the power n, then 5x to the power 5 minus 1. We know that d dx of x to the power n, nx to the power n minus 1. Here n is 5. So 5x to the power 5 minus 1, power minus 1, using formula d dx of x to the power n. So student, here 5x to the power 4. 5x to the power 4 by 2 root over sine inverse x to the power 5 root over 1 minus x to the power 10. Here using formula d dx of x to the power n equals to n x to the power n minus 1. So here x to the power 5 means 5x to the power 5 minus 1. So result will be 5x to the power 4 by 2 root over sine inverse x to the power 5 into root over 1 minus x to the power 10. I hope that student you are clear. Student, question number 6t. d dx of tan inverse 4 root over x by 1 minus 4x. So we have d dx of tan inverse, we can write 2 into 2 root over x, 2 into 2 root over x by 1 minus 2 root x whole square. Student, here 2 into 2 root over x means 4 root over x, and 1 minus 2 root over x whole square means 4x. So we can write 4x equals to, 2 root over x whole square. Attention please student, you have learned d dx of, 2 tan inverse x equals to tan inverse 2x by 1 minus x square. You have learned student formula tan inverse 2x by 1 minus x square equals to 2 tan inverse x. So student, memorize it using trigonometric formula tan inverse 2x by 1 minus x square equals to 2 tan inverse x. So here x is 2 root over x. So 2x by 1 minus x square. Now using formula tan inverse 2x by 1 minus x square, using this formula. Here 2 tan inverse x, x means 2 root over x. I say again student, here using this formula 2 tan inverse x, here x is 2 root over x. Now take it to the first position of 2, then we get d dx of tan inverse 2 root over x. Again using formula tan inverse x, we know that tan inverse x equals to 1 by 1 plus x square. Then d ddx of 2 root over x. So we have 2 by 1 plus 4x and take it to the first position of 2, then ddx of root over x. So 2 into 2 equals to 4 by 1 plus 4x into 1 by 2 root over x. 1 by 2 root over x. We know that ddx of root x equals to 1 by 2 root over x. 2 and 4 cancel, then we get result will be root over x into 1 plus 4x. So here result will be 2 by root over 1 plus 4x, root over x into 1 plus 4x. So student here memorize it. Tan inverse 2x by 1 minus x square equals to 2 tan inverse x, and ddx of root over x equals to 1 by 2 root over x. I hope that student you are clear. Question number 73. ddx of tan inverse sec x plus tan x. It's very important question for your exam. So student, we know that ddx and tan inverse x, then here sec x, we know that sec x equals to 1 by cos x and tan x equals to sin x by cos x using formula. I say again student, here sec x equals to 1 by cos x, tan x equals to sin by cos x. Then ddx of tan inverse, here LCM is cos x, so numerator will be 1 plus sin x. Then ddx of tan inverse x, we can write 1 equals to, attention please student, here 1 equals to cos squared x by 2 plus sin squared x by 2. Student attention please, here 1 equals to cos square x plus sin square x, then x means x by 2, x by 2, and sin x, sin 2 into x by 2. Again denominator will be cos 2 into x by 2. So student, here next line, ddx of tan inverse x, ddx of tan inverse x, cos squared x by 2 plus sin squared x by 2, this is 1, and using formula sin 2a. Student, here using formula sin 2a, we know that sin 2a equals to 2 sin a into cos a. So 2 sin a into cos a. Next denominator will be using formula cos 2a. We know that cos 2a equals to cos square a minus sin square a. So we can write cos square x by 2 minus sin square x by 2. Student, memorize it. Sin 2a equals to 2 sin a cos a, and cos 2a equals to cos square a minus sin square a. Then ddx of tan inverse, here using formula a square plus b square plus 2ab, a plus b whole square. So a plus b whole square, here a means cos x by 2, b means sin x by 2, and denominator will be using formula a square minus b square. A square minus b square means a plus b, a plus b into a minus b. B means sin x by 2. Then next line, here ddx of tan inverse cos x by 2 plus sin x by 2 and cos x by 2 plus sine x by 2, and denominator will be cos x by 2 plus sine x by 2, and here cos x by 2 minus sine x by 2. Then here cos x by 2 plus sine x by 2, cos x by 2 plus sine x by 2 are cancelled. Then next line here ddx of tan inverse cos x by 2 plus sine x by 2, and denominator will be cos x by 2 minus sine x by 2. I say again student, here using formula a square minus b square equals to a plus b into a minus b, then we get tan inverse cos x by 2 plus sine x by 2, denominator is cos x by 2 minus sine x by 2. Now ddx of tan inverse dividing all expression by cos x by 2, dividing numerator and denominator by cos x by 2. Here denominator will be cos x by 2 by cos x by 2 minus sine x by 2 by cos x by 2. Student, attention please. Dividing numerator and denominator by cos x by 2. Then we have ddx of tan inverse. Here cos x by 2 cos x by 2 cancel, cos x by 2 cos x by 2 cancel. So numerator will be 1 plus sine by cos means tan x by 2, and we know that sine by cos, sine x by cos x equals to tan x. Here x is x by 2, and new denominator will be 1 minus tan x by 2. So student, next line ddx of tan inverse, we know that 1 equals to tan pi by 2. 1 equals to tan pi by 2. So we can write 1 equals to tan pi by 4. We know that 1 equals to tan pi by 4. Now tan pi by 4 plus tan x by 2, denominator will be 1 minus tan pi by 4 into tan x by 2. I say again student, we know that 1 equals to tan pi by 4 plus tan x by 2, and denominator 1 minus tan pi by 4 means 1 and tan x by 2. Then using formula tan a plus tan b by 1 minus tan a tan d. Now here ddx of tan inverse tan a plus b pi plus x by 2. Tan inverse cancel, then we get pi by 4 plus x by 2. So student, here separating all expression, pi by 4 plus ddx of x by 2. We know that ddx of pi by 4 is constant, so ddx of constant equals to 0. So ddx of pi by 4 equals to 0. And here half is constant, so take it to the first position, and ddx of x is 1. So result will be half. So student, result will be half. I hope that student you are clear. Student, question number 82. ddx of tan inverse root over 1 minus cos x by 1 plus cos x. Now ddx of tan inverse root over 1 minus cos x is, we can write 2 into x by 2. Student, attention please. X equals to 2 into x by 2. So 2 cancel, then same as cos x. Similarly, denominator will be 1 plus cos 2 into x by 2. Now d dx of tan inverse root over, now using formula 1 minus cos 2a. So student, you have learned formula 1 minus cos 2a equals to 2 sin square a. We know that 1 minus cos 2a equals to 2 sin square a. So student, here using this formula in numerator, 1 minus cos 2a, a means x by 2. So 2 sin square x by 2. Attention please student, here using this formula 1 minus cos 2a equals to 2 sin square a means x by 2. Similarly, we know that using formula, we know that 1 plus cos 2a equals to 2 cos square a. So using this formula in denominator, so we can write 2 cos square x by 2. So student, d dx of tan inverse 2 cancel. We know that sin square theta, sin square x by 2, cos square x by 2. Sin square x by 2 by cos square x by 2 equals to tan square x by 2. Then d dx of tan inverse x, here square and root cancel, then we have tan x by 2. Here tan inverse tan, using formula tan inverse x by 2 means x by 2. Here x by 2, 1 by 2 is a constant, so take it to the first position. So we can write 1 by 2 d dx of x. We know that here half into, we know that d dx of x, we know that d dx of x equals to 1. I say again student, d dx of x using formula d dx of x equals to 1. So result will be 1 by 2. Result will be 1 by 2. I hope that student you are clear. So it is very important question for your examination. So see you again next class. Allah Hafiz.